All right, continuing on here, we're going to talk about run or control charts. For our purposes here, they're pretty much the same thing, but you might see them under two different names. There's actually a lot of different types of control charts, but we won't go into that in this course. Just be aware there are many different types. All right, so the difference between the histogram in the video we just looked at and this one is that the run and control charts show it over time. All right, so in this example, we're going to have a center line, sometimes called X bar. This is your mean, so your mathematical mean is going to display your data from the first or oldest to the last or more recent, again, over time. That's important. All right, and then the variable being measured is on our y-axis. So again, the opposite of the histogram, where the variable being measured is on the x-axis. All right, so then we have these different zones. Zone A is the outer one, B, then C. Don't ask me why they're in that order. I would have labeled them A as in the middle, and then B, and then C, but that's not the way they are. So if you remember when you learned about standard deviation back in your Stats 145 days, so we have plus or minus one standard deviation is 68.3% of all points. So if we have 100 points, 68 of them will always fall within plus or minus one standard deviation. So 34% above, 34% below, totaling 68%. Then our next zone is plus or minus two standard deviations. So this is 95.5% of all of your data points will fall between those two. And then finally, the upper and lower control limit, so that's a term you want to learn, your upper and lower control limit are plus or minus three standard deviations, and that will be almost all of your points, 99.7% of all data points will fall within plus or minus three standard deviations. So a couple of terms you'll need to know in this course. There's an upper spec limit and a lower spec limit, USL, LSL. Spec limits are specified by the customer. UCL and LCL are upper control limit and lower control limit, and these are controlled by the process. So our plus or minus three standard deviations, that is the upper control limit, the mean plus standard deviations. The lower control limit is the mean minus three standard deviations. So you'll want to be able to calculate that. That's a potential quiz and or exam question. So again, the upper control limit, mean plus three standard deviations, lower control limit, mean minus three standard deviations. These are not at all related to the LSL and USL. We'll get more into those when we start talking about CP and CPK. These are our zones, as I talked about. So we won't really do a lot with the zones at this point, but they are used for identifying which points are outside of statistical control, which ones have special cause variation. So within these zones, the way we build this chart is we build the center line, we drop all of our points in order, just like that, and then you lay your zones down on top of it. So then let's move on to interpreting these control charts. So to interpret these, we're looking for special or assignable cause variation. So special versus common cause. Common cause is inherent in the process. It's very difficult to remove from the process. Generally causes a small amount of variation. Special cause is the low-hanging fruit. These are more easily identifiable and removed, not always easy, but more easily, and they generally cause a larger variation than special cause is usually a larger amount of variation than common cause. So examples, common cause, we see wear and tear on equipment, expected variation within materials, slight changes in heat or humidity within a building. Special causes, things like equipment being set up improperly, being set up for the wrong product, a bad batch of material. So not just normal variation. If you're expecting a 2x4 to be 8 feet long and it's plus or minus a couple of 1/16 of an inch, That's generally considered a common cause. Special cause is it comes in only 6 feet long rather than 8. Extreme temperature changes. So this is maybe your HVAC system breaks down, work is slow, or metal starts to expand and causes parts to be bad. So we have a few rules. These are called the Western Electric rules, and I'll provide a link to these as well. So any single data point that falls outside of the 3 sigma limit. So 99.7% of all parts should be within that plus or minus 3 standard deviation. But if we have any parts that are out, we look at that and we assume that that is special cause variation. 2 out of 3 consecutive points fall beyond the 2 sigma limit. So it's zone A or beyond on the same side of the center line. So we have a couple of occurrences here. You can see they don't have to be 2 in a row. It can be 2 out of any 3. Again, that's only about 5% of all of the parts should be outside of that zone. So if we see 2 out of 3, that's highly unlikely to be normal variation. We're looking for that special and assignable cause to have caused this. 4 out of 5 consecutive points beyond the 1 sigma limit. So we see 1, 2, that one's in, 3, 4. 4 out of 5 beyond the 1 sigma limit. Again, on the same side of the center line. Again, 68% of our points are supposed to be within these. Right? So if we see 4 out of 5 outside of it, that's a lot of points outside of that. So again, this causes us to say that something was likely assignable cause there, and we need to go investigate. Then finally, 8 consecutive points on the same side of the center line. 50% of all our points should be on either side, so 8 consecutive points in a row. This tells us again that there's something going on and we need to further investigate. And that's it. I will provide a link to the Western Electric rules as well, so you can research those. Let me know if you have questions.